All right, so last objective for Unit 3 is Objective 3.2b. And it's just we're going to clean up and make sure we know as much as we can about inverse functions before the test. So today's objective, you'll be successful when you can evaluate compositions with inverse functions. So evaluate, we're going to plug numbers in, but now we're plugging them into inverse functions. So how do we do that? And then you can graph inverse functions and use a line test to prove that they're true inverses. So instead of doing the inverse theorem that we were working on yesterday, where we were plugging one function into the other to see if they would undo each other inversely, we're going to do it with a graph. And it's nice, it's visual, and you can just immediately see, yeah, these are definitely inverses. Like the horizontal line test and the vertical line test, the line test for inverses is also pretty immediate. You can see it, okay? All right, so here are some notes just to remind you. Some of this might be a repeat of yesterday. We shall see. Let's start with about inverse functions. Let's remember that inverse functions, oh, I didn't spell that right. I type it wrong often too. Yeah, you have no idea. You gotta remember to spell the word fun. Functions are fun. Yeah, right. Inverse functions only exist if f of x is 1 to 1. So that's important. Remember, if it's 1 to 1, each x has one y, each y has one x. They don't cheat. They don't trade partners. They are 1 to 1. Okay. Also, there was something else that I wanted to say about that, but my note page over here on my iPad went to sleep. Okay. Remember that when you're finding inverse functions, the x's and y's, that's my sign for and y's, switch places or interchange. Okay. So that's what I wanted to say about that. There's some more things that I want to say. The line test for inverse functions says this: if f of x and f inverse of x are true inverses, I added the word true there, then they are symmetric across y equals x. And that's the line that you will use for your line test. And we will, when we graph it, remind me that I'm supposed to graph it as a dashed line, not a solid line. Okay. Then one other thing that I want to remind you about. So big reminder here. I always say these things are important, and I mean it. If the x's and y's switch on inverse functions, f's domain equals f inverses range. And I move my little menu out of the way over here. And vice versa. F's range will switch to f inverses domain. And we will see that really clearly on the graphs today. So those are the three things that I wanted to just bring back to the forefront of our minds. Okay, so here we go, down to the guided practice. Last week, or maybe Monday, I don't remember, maybe Monday, we learned how to evaluate compositions of functions using tables and graphs, etc. So we're going to be doing the same thing again today, but we're going to be evaluating these compositions that include inverse functions. So this is evaluating compositions again, or composite functions. Okay? Yes, you may. So I think that this thing that I'm about to do, I would like for you to write in your note page. Now, you may be able to get through this process of answering all these questions without this little intermediate step that I'm going to do, but I think it's going to make some things clear for everybody. All right. So the first thing I'm looking at is I look at all these compositions where I'm plugging a value in, and I'm seeing a lot of inverse notation. So what I want to do before I confuse myself is I'm going to go ahead and find the inverse. This is my f of x. So I'm going to grab my red pen here, and I'm going to find x and f inverse of x's points. So I'm just going to do another table, if you don't mind. So what do we know about the points for functions and their inverses? What do the x's and y's do? Switch. So instead of x being my input and -1 being my output, in the inverse, -1 is my input and 2 is my output. They have to switch. So we could continue. 0, 3, 1, 4, 2, 5, 3, 6. And that's basically what we're doing. Even when we're doing all that algebra, we're just switching the x's and y's. We're just not evaluating, plugging in numbers. All right, I'm switching to green. Now I'm going to look at my g of x set of points right here. So if I want to do my g inverse of x, these sets of points help me out. Instead of -1 input, 1 output, 1 input, -1 output. How about this point? 2, 3. Where are you guys? 3, 2. Wake up. Okay, and the last point I have here, 3, 5, 5, 3. All right, so now we've evaluated and we found all those points. All right, last one, your h of x. Now is a different format. This is an algebraic representation. It's an equation. Okay, so I say we'll just find some points. We'll just do another table of values, and then we'll find their inverses. So we're going to do x and h of x, and then we'll go back and we'll do x and h inverse of x. Okay, ready? So I'm going to pick some points for x. Let's pick -2 and -1 and 0, 1, 2, and 3. Yeah, let's do all of those. Okay, so we'll plug them in real fast. This is just linear, so once we get the pattern going, we're going up on the x's. Let's see what's happening on the y's. What's 4 minus -2? That means 4 plus 2 is 6. And let's do 4 minus -1. That's 4 plus 1 is 5. All right, look at the pattern. As my x's go up 1, my y's are going down 1. And since it's linear, I can just go ahead and finish that pattern out. Okay. So there's my h of x set of x's and y's, or coordinate pairs. Switch them out. 6, 5, 4, 3, 2, 1. -2, -1, 0, 1, 2, 3. They just switch. So there we have all of these points. And remember, when we're doing compositions and we're evaluating, we go from input, replace it with output. Remember? Input, output, input, output, input, output. So here we have our first problem. G inverse composed with F inverse of 2. So we have to start with the F inverse of 2 because we're plugging the 2 into the F inverse. All right, so G of 1. And what is the F inverse of 2? So I go to my F inverse of 2. That's my input. What's my output? 5. My F inverse of 2 is 5. Now I know that I'm going to compose my G inverse, not compose, but input, my G inverse of 5. So input 5, output 3. There it is. Okay. Let's go to this one, G inverse of H of 3. So we're going to start composing, plugging a 3 into H. So here we go. When H is 3, what's your H of X? 1. So the G of negative 1, or G inverse of 1. So now we go to our G inverse. We plug in a 1, we get out negative 1. Okay, put a star next to this one. There's a question like this on the test, and it's a triple composition. Heart attack. How do we read that? Okay, it looks like this. The H inverse of G inverse of F of 6. Actually, that F doesn't have a parentheses on the back of it. Let me fix that up. Can we close the door, please? The F of 6. Okay, notice that I have 3 open parentheses and opening, so I got to close it 3 times. 1, 2, 3. There it is. Okay, so we're going to start with evaluating the F of 6. So what is the F of 6? The F of 6 is 3. All right, so we're going to replace the F of 6 with 3. Now we only have 2 sets of parentheses because every time we work down, we remove a set of parentheses. All right, now we're going to the G inverse of 3. So the G inverse of 3 is 3. G inverse of 3 is 2. Yep. It's 2. And now 1 set of parentheses. So now we're going to replace the H inverse of 2. So we go to the H inverse, that's this one, of 2 is what? It's 2. And so triple composition, evaluation, and you did it. Okay, your turn. You do these next set of A's and B's. I don't know why that doesn't say D and E. You know how I always have a typo on my notes. Okay, so your D was 3 and your E was 5. Okay, next set of problems. Now we're going to go to actual graphs, and we're going to be proving that these 2 sets of problems are each part of the problem is an inverse of the other part. So let me just get my graph up here. All right, so we are going to be using that line test that I was talking about. I'm going to have a little more room here. Too far. Where's my mouse? It's over there. Okay, there we go. All right, so question? Yes. Uh-huh. The F inverse, well, your G inverse of 3 is 5. You're right. Thank you. My answer was right? Yeah, right. I just wrote it down wrong. Thank you. Thank you for that. All right, here we go. Okay, so remember what I've told you. In order for a function to have an inverse, it has to be 1 to 1. So when I look at my first function here, and I'm going to do my f of x's and my original functions in red, when I look at that, I go, wait a second, that's a parabola. Parabolas aren't 1 to 1 because part of the parabola is increasing and then it turns and it decreases, and that fails the horizontal line test. However, we do have a domain restriction here. So we're only graphing part of the parabola. So let's just see what happens when we do that. So we're going to work off of this domain right here, where we're going to pick x is less than or equal to 0. So I'll pick 0, -1, and -2, because I can do the math with those pretty quickly. Oops. And we'll plug some points in, and we'll see if we've defined this parabola as 1 to 1 because we've restricted it to one side of the parabola. So let's see, plug in a 0. 2 minus 0 squared is 2. Okay. 2 minus negative 1 squared. Well, negative 1 squared is 1. 2 minus 1 is 1. And then 2 minus negative 2 squared. Well, negative 2 squared is 4. 2 minus 4 is negative 2. So let me see this. As my x's decrease, my y's do what? Decrease. I think that's 1 to 1. Okay. Now, I'm going to go ahead and go to my graph, and I'm just going to go with my pencil, and I'm going to mark some little tick marks on here. So every other line will be 1 unit. Of course, you can do yours however you want. But when I'm doing a test for inverses on a graph, I like to give myself a lot of white space, so a lot of in-between space to see the symmetry. Because when things get too close together or jammed together, it's hard to see symmetry. So that's just my advice there. Okay. All right. So I'm going to graph those 3 points of my parabola. 0, 2, negative 1, 1, negative 2, negative 2. And I'm going to connect them with a curve. And I know I'm going to continue going left, and I'm going to continue going down. So there it is. I didn't do a very good job. I'm going to draw that again. That's not good. There we go. That's better. Okay. Definitely 1 to 1, right? Yes. Okay. So that means we can find its inverse. Well, here's what we know about inverses. If we're being smart mathematicians, when I go to do my f inverse of x, what do I know about their x's and y's? They switch. So what x's am I going to choose? Which x's am I going to choose? 2, 1, and negative 2, because I want to pick the y's from my f of x. Okay, let's plug them in and just make sure. Let's make sure. So let's plug in a 2. So the square root is 2 minus 2 is, square root of 0 is, and the opposite of 0 is 0. Okay, I got it. So that looks good. 0, 2, 2, 0. I like it. Let's plug in a 1. 2 minus 1 is, square root of 1 is, opposite of 1 is, I like it. 2 minus negative 2 is 2 plus 2. Square root of 4 is, opposite of 2 is negative 2. Oh, those look like inverses to me. So let's graph them. 2, 0. 1, negative 1. 2, negative 2. Oh, I did. Back it up, frame. Fail. That's okay. You guys are great at catching my mistakes, and I always appreciate them because you're not jerks about it. Graph it. So instead of drastically dropping, I have to do the opposite. I'm going to drastically go to the left. Okay, so there's our graph. So now we're going to put in our line test. Our line test is the line y equals x. So whatever x equals, y equals, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. Notice that my two inverse functions actually intersect my line of symmetry. They're supposed to. They are supposed to. So this right here, that they're intersecting right here, is a good indication that they are inverses. That's one little test. It's certainly not, you can't just test that point and say you're good. That certainly won't work, but it is a good indicator. Are those graphs symmetric across this line if I fold on this dotted line? Yeah. So let's go back and label that. That's y equals x. That's your test line for symmetry. And then this was our f of x. And let's identify, what is the domain of our f of x? Read it left to right. Negative infinity to 0 closed. How about our range? Bottom to top. 2. All right. Now, if these are really inverses in another way, their domains and ranges should switch. So let's see. What is the domain of my blue function here? Left to right. Domain. To 2. Oh, that's supposed to happen, right? Yep. How about its range? Bottom to top. No, bottom to top. It tops out at 0. There it is. Look. Another test. They're definitely inverses. Got it? Okay. So let's make our tick marks on the other one exactly the same. Hurry up, Skylar. What you need? Okay. Now, I will tell you that on the test, on Friday, one of these two problems, now I should say one of these two problem types, I'm not going to guarantee that they're the exact problems, will be on the test. You will have to not only prove that they're inverses graphically, you will have to prove that they're algebraically. You'll have to compose them inside of each other and show that they undo each other. Okay? All right. So let's go to our h of x up here. Is it 1 to 1? How do you know it's 1 to 1? Because it's a line and it's always increasing. Yep, for sure. So it definitely passes the vertical line test. Let's graph it. Your y-intercept's -3. You got a slope of rise 2, run 1. Make sure you're rising 2 whole units. Draw your line. And let's label it f of x as we go. Oh man, that's really hard to do. Lines on my tablet here. I'm sure yours is better. And that's an h of x. Okay. What do you need to know about the inverse? Is that a line? I think it's a line. Does it have an x in the denominator? Oh, and it is x to the first power. So you know I'm going to show it a little love, and I'm going to separate it so I can see my slope and I can see my y-intercept. So what's the coefficient of my x? So 1/2 x plus 3/2. Look, here's another tip for inverses. I mean, you cannot not find inverses here. The slope of my h of x was 2 over 1. What's the inverse of 2 over 1? 1 over 2. So its slope will be the inverse because they're lines. So there you go. So let's go to 3/2 or 1.5. Graph our y-intercept. And be careful because you're rising not 1/2. You're rising 1 and running 2. So go all the way up 1 unit to 2.5 and go right 2. And up 1 unit and right 2. 1, right 2. You could also go down and left. Down and left. Down and left. Okay. So there's our h inverse of x. And their domains and ranges are unrestricted, right? Because they're lines, left to right forever, up and down forever. So I don't even need you to find the domains and ranges of these. Okay, let's put in our line of symmetry. Look at where they intersect. What point did they intersect at? What? Oh, shocked. Look at you, Isaac. You're so good at pretending you're shocked. They do intersect on the line of symmetry. They intersect at 3, 3, right? Because in order for their x's and y's to switch places and for them to be inverses, they have to intersect at an xy that's exactly the same, 3, 3, and 3, 3, or -1, -1. So they intersect at 3, 3, so that's a good test that they're inverses. Are they symmetric? Yes. Okay, one other little tidbit of information that I think is really interesting. Let's go back to our graph and let's take a look at our red graph right here. This point right here that I'm pointing at right here is what point? What's that point? 2, 1. So its inverse or its corresponding point is what? 1, 2. And look at it, it's on that line. But here's what I'd like you to do. I would like you to draw a line segment connecting the corresponding points. Here's another interesting test to prove that these are inverses. When you draw a line segment to connect the corresponding points, the line segment will be perpendicular to the line of symmetry. And all of the corresponding points, all of them have that in same idea. Look over here. If I do it over here, look. If I connect 1, -1 with -1, 1, perpendicular to y equals x. I think it's kind of interesting that that happens. Okay, so your homework is on Canvas, and it's due tomorrow.